this video, we are going to see DDA algorithm. Before moving into DDA algorithm, we will see some of the concepts in line drawing. Okay. Basically, we use the Cartesian slope-intercept equation for a straight line, that is y is equal to mx plus b, to draw a straight line using line drawing. Look at this. Okay. Here, in y equal to mx plus b, m represents the slope of the line and represents the y-intercept, and x and y are the coordinate positions. Okay, so given two endpoints of a line segment, as shown in this figure, here the two endpoints are x1, y1 and x2, y2. Okay, given two endpoints x1, y1 and x2, y2, we can determine the value of slope m using the equation y2 minus y1, y2 minus y1 by x2 minus x1. Okay, that is delta y by delta x. Okay, and also we can find the value of b, y-intercept b, using the equation b equal to y1 minus mx1. Okay, so using these equations, we can draw a line using the algorithms. Okay, or the algorithms that are displaying straight lines are basically based on these three equations. Okay, so for a given x interval delta x along a line, we can compute the corresponding y interval from the equation 2 as delta y equal to m delta x, and similarly we can obtain x interval corresponding to a specified y interval as delta x by delta y by m. Here both these equations are derived from equation 2. Okay. From this equation 2 here. So from this equation, equation 4 and 5 is derived. Okay, that is delta y del m is equal to delta y by delta x. So delta y can be calculated using the equation m delta x if delta x or the x interval along a line is given. And similarly, if delta y is given, then delta x can be calculated by the equation delta x equal to delta y by delta m. Okay, that is if equation 2 is m equal to y2 minus y1 by x2 minus x1. That is equal to delta y or y interval by delta x. Okay, this was equation 2. Okay. Okay. This was equation 2. So here y interval delta y by x interval delta x is the slope m. Okay, from this equation we have derived the equation 4 and 5. That is equation 4 will be derived. That is here. So delta y can be determined if delta x is given using the equation delta y equal to m into delta this m into delta x, that is derived from equation 2. And similarly equation 5 is also derived from equation 2. That is, if delta y is given, then you can determine when delta y is given, you can determine the value of delta x using the equation delta x is equal to m divided by delta y. So both these equations are derived from the equation 2, the previous equation 2. Equations form the basis for determining deflection voltages in analog devices. Okay, so in analog devices, for lines with slope magnitude, that is absolute value of m less than 1, delta x can be set proportional to a small horizontal deflection voltage, and corresponding vertical deflection is then set proportional to delta y, which is calculated from the equation 4. That is equation 4 is this. Okay, that is delta y equal to m delta x. So when the slope, the magnitude or the absolute value of a slope is less than 1, you can set the delta x to a small voltage, and you can use this equation delta y equal to m delta x to determine the value of y. Okay, and if this value of a slope is greater than 1, that is the magnitude of the slope, that is absolute value of m is greater than 1, then we set delta y, that is a small vertical deflection voltage is set, and the corresponding horizontal deflection voltage is found using the equation 5. That is this equation delta x equal to delta y by m. Using this equation, you can find the value of delta x, and if the value of slope is equal to 1, then delta x that equal to delta y, that is horizontal deflection voltage and vertical deflection voltages are equal, and so you can draw a line using those values. So in this case, in case of analog devices, using this equation directly, when x1 y1 and x2 y2 values are given, then you can directly use this equation, that is equation 4 and equation 5, based on the magnitude of the slope. You can determine the you can draw a line. Okay, you can draw a smooth line using these equations. Okay, in case of analog devices like in random scan systems or a pen plotter and all, you can draw a line, smooth line, directly using these equations. Okay, but in case of raster systems, lines are plotted with pixels, and step sizes in horizontal and vertical directions are constrained by pixel separations. Okay, so we have to sample a line at discrete positions and determine the nearest pixels to the line at each sample position. Okay, that is, we want to draw a line like this in our raster system. So in raster system, each line, any picture is displayed by scanning from top to bottom, line by line. Suppose these are scan lines. These grid positions show it's the pixels. Suppose it shows the pixels. Then what the raster system does is, it will scan from top to bottom from each scan line and determines which pixels are should be displayed, okay, based on the values of the pixels, each pixel positions. Okay, so if you want to draw a line like this, what happens is, you have to plot it with pixels. Okay, so this step sizes will be constrained with pixel separation. So what happens is, here you can see that it's not, each point is not in particular pixel, right? So what happens is, you have to constrain it to this pixel separation. So what we do is, we sample this line at discrete positions and determines the nearest pixel value, and that pixel values will be displayed. So that's why we've already said that a kind of staircase step like images may occur in a low resolution picture. So what you do is, we draw a line like this, and you sample it along the x-axis or y-axis into unit intervals, and you determine some positions, and the nearest pixel values to that positions are determined, and you display those pixel values to determine the to draw the line. Okay, so this scan conversion process is shown or illustrated in this picture. So we are sampling a line at discrete positions like this, and you determine the corresponding other coordinates, okay, using the equations we have seen. Okay, so DDA algorithm is basically digital differential analyzer, and it is a scan conversion line algorithm. Okay, so basically it is used for scan converting a line based on calculating either delta y or delta x using the equation 4 and 5 Okay, so we sample a line at unit intervals in one coordinate and determine the corresponding integer values nearest the line path for the other coordinate. Okay, so that is basically DDA algorithm. Okay, so what is that the DDA algorithm does? You sample a line at unit intervals in one coordinate, that is either we take x coordinate and sample it at unit intervals and determine the corresponding y coordinates, or you take y coordinates, sample it at unit intervals in the y coordinate, and you determine the corresponding x coordinates using the equations 4 and 5. Okay, so that is what we do in DDA algorithm. Okay, so in case of DDA algorithm, there are two cases, that is positive slope and negative slope. Okay, positive slope means if the x values are increasing, correspondingly the y values also will be increasing. Okay, and in case of negative slope, when the values of x values are increasing, the y values will be decreasing, that is negative slope. Okay, so here this is a example of a positive slope. Okay, so here when x values increase, here x values increase from 0 to some xm, and here y values are also increasing from 0 to ym. So when x values increase, y values are also increasing. So this is a positive slope. Okay, so in case of positive slopes, in case of positive slope, if the slope is less than or equal to 1, we sample the unit x intervals and compute each successive y values as yk plus 1 equal to yk plus m. Okay, so that is, if the value of m, if the slope is less than or equal to 1, means the value of m is less than or equal to 1, or it is between 0 and 1. Okay, so if the value of m is between 0 and 1 in case of a slope, positive slope, then we sample the x intervals. That means the x coordinates are sampled at unit intervals. Okay, so x coordinates delta x will be equal to 1, and we compute corresponding y values or successive y values using the equation yk plus 1 equal to yk plus m, where the k takes integer values starting from 1 for the first point and increases by 1 until the final endpoint is reached. Okay. Okay. So next is if the slope is greater than 1. So one case is if the slope value is less than or equal to 1. Then the other case is if the slope value is greater than 1. Then what happens? We reverse the roles of x and y. That is, we are sampling the y intervals. Delta y will be equal to 1 here. And then you find the successive x succeeding x values using the equation xk plus 1 equal to xk plus 1 by m. Okay, so these equations, that is equation 6 and equation 7, both these equations are derived from equations 4 and 5 correspondingly. Okay, that is equation 4 is delta y is equal to delta m delta x. That is equation 4 that we have seen earlier. Okay, that was equation 4. Okay, so in case of a slope value less than or equal to 1, you are going to sample at unit intervals delta x is equal to 1. So the value of delta x is equal to 1. So from this, both these equations, you can get delta y is equal to m. Okay, then we know that delta y can be also written as yk plus 1 minus yk, right? That is, if you take each y interval, the value of k is starting from 1 for the first point and increases 1 each time till the final endpoint is reached, right? So the first position, the value of k is equal to 1. So delta y is y2 minus y1. Then the next position, the value of k is 2. Then the delta y is y3 minus y2. Okay, that's how it proceeds. So delta y can be written generally as yk plus 1 equal delta y equal to yk plus 1 minus yk, right? So from both of this, you can write yk plus 1 minus yk is equal to m. So from this, you can determine the value of yk plus 1 is equal to yk plus m. Okay, so this is equation 6 that we have seen now. Okay, similarly, you can find the equation 7. Uh, Equation 7 is derived from equation 5. That is, equation 5 is delta x is equal to delta y by m. That was equation 5. Okay, so that was equation 5. From this equation, we know that if the value of slope is greater than 1, then you are going to sample at unit y intervals. Okay, so the value of delta y is equal to 1. Okay, so the value of delta y is equal to 1. Okay, so from both this equation, you can write delta is x is equal to 1 by m, right? And we know that the x interval delta x can also be written as xk plus 1 minus xk. Similarly, we have written delta y. Similar thing is happening here. That is, each time the value of k is incrementing by 1. So first position, k value of k will be equal to 1. That means delta x will be x2 minus x1. So similarly it continues. So we can write delta x as xk plus 1 minus xk. Then from both this equation we can write xk plus 1 minus xk is equal to 1 by m. So from this you can determine the equation 7, that is xk plus 1 is equal to xk plus 1 by m, that is equation 7. Okay, so that this equations 6 and 7 were based on the assumption that the lines are to be processed from left endpoint to the right endpoint. It's also possible that you can draw the line from right endpoint to the left endpoint. If you've drawn the line from x1 y1 to x2 y2 from left to right, then this equation 6 and 7 should be used. If suppose you have to draw it from right endpoint to left endpoint, then you have to use a different equation. That is simply you have to take the unit intervals in negative values. That is, if we are processing in the reverse direction, that is from right to left, then the starting endpoint is at right, then we have delta x equal to minus 1, and then the value of yk plus 1 will be equal to yk minus m. Okay, so here delta x value is equal to minus 1, so it will be m into minus 1, so it will be minus m. Okay, so yk plus 1 equal to yk plus m into minus 1, so that is yk minus m. And if the value of slope is greater than 1, then delta y will be taken as minus 1, and then xk plus 1 will be equal to xk plus 1 by m into minus 1, that is xk plus 1 equal to xk minus 1 by m. That's the only difference if you have to draw it from right to left. Okay, then that was the case of positive slope. Suppose you have to draw a negative slope, or if in negative slope, what happens, as the value of x increases, the value of y is decreasing. So the value of m, that is delta y by delta x, will be equal to some minus value or a negative value, that is negative slope. Okay, so then we use the same equations from equation 6 to equation 9 that we have seen here, that is equation 6, 7, 8 and 9. These equations itself is used, only that when you take the value of m, you take the absolute value of the m. That is the value of m will be negative, so you take the absolute value of m, that is, so that the value will be positive. So then if the absolute value of the slope is less than or equal to 1, you use the equation 6, and if it is from drawn from left to right, and if it is from right to left, then you have to use equation 8. Then similarly, if the absolute value of the negative slope is greater than 1, then you have to use delta y equal to minus 1, then you use equation 9, and if the value of delta y is equal to 1, that you have drawing from left to right, then you have to take delta y equal to 1, and you use equation 7 to find the to draw the slope, draw the line. So this is the procedure for DDA algorithm, that is the algorithm that I have described now is summarized in this procedure. So in this procedure, it takes the two endpoint pixel positions as input, that is this XA YA and XB YB shows the two endpoint pixel positions. Okay, and the horizontal and vertical difference between the endpoint positions are assigned to the parameters dx and dy. That is basically the delta x and delta y that I have told before. That is dx, the value of dx is the horizontal difference, that is xb minus xa, and the value of dy will be the vertical difference, that is yb minus ya. Okay, then the difference with the greater magnitude will determine the value of the parameter steps. That is, which value is greater. If the value of dx is greater, then the steps will take the value dx, and if the value dy is greater, then steps will take the value dy. So for that you have this if else condition. Okay, so if the absolute value of dx is greater than absolute value of dy, steps is equal to absolute value of dx, else the value of steps will be equal to absolute value of dy. Okay, then what we do is, after finding the value of steps, you are starting with the pixel position xa ya, then we determine the offset needed at each step to generate the next pixel position along the line path. That is, you find the x increment and y increment. That is, for each step, how much the value of x and y should be incremented. That is determined using the equation dx by steps for x increment and dy by steps for y increment. Okay, so so this is the offset values needed at each step. Okay, then we loop through this process steps times. Okay, so using this loop, we using this for loop, you move the values from k equal to 0 to k less than equal to steps, and at each k value you are going to increment the value of x and y, which are the pixel position. So starting position of x y, starting pixel position x y is xa and ya. From that position you are going to increment one step each, and you are going to plot each pixel positions. Okay, so the first position of xy is xa ya. That position is set, or using the low level command set pixel round of x, round of y. That is, round x, round y is taken because you have to find the nearest integer value if of x and y. So round x, round y, that xy position is set using the set pixel, which is a low level command to display a pixel position. Okay, so using this command, the first position will be xa ya. Then next position, the value of k is equal to 0. You are going to increment the value of x and y with x increment and y increment correspondingly, and you are going to display that particular x and y value, and it continues until the value of k is equal to value of steps. Okay, and we have studied that if the value of m is less than or equal to 1, then delta x is equal to 1. So here, when you are when you are determining the value of steps, that's what happens. That is, when the value of when the magnitude is less than or equal to n, less than or equal to 1, then the value of dx will be greater than dy. Okay, so then here the value of step will be dx. Okay, so if the value of steps is dx, then the x increment will be always equal to 1, and y increment will be dy by dx, that is equal to m. So we are using the same equation 6 for this case, and if the value of if the magnitude of m, or the slope, is less than greater than 1, then that means that dy is greater than dx, so the value of steps will be equal to dy. Then the y increment will be always equal to 1, and x increment is determined using the equation dx by steps. Okay, so here we are actually using the equation 6 to 9 only to determine the value of x and y at each steps. Okay, so this is summarized in this procedure. Okay, thank you.